Okay, hello everyone. Welcome to the first discussion for the Winter 21 semester for EECS 494. I'm your GSI, Ish, and for the first discussion of the semester, these discussions are essentially meant to be optional, additional material to help you out in the course with different parts of projects or just how to use Unity in general. Um, the first discussion that we're going to talk about, I'm going to go over something, a feature of the animator in Unity called blend trees. Um, this feature, it's a little bit more advanced of a feature, but it if you take the time to use it and understand it, it can be really useful, especially if you're doing the Zelda game for your Project One. It'll also be useful in Metroid if you choose to use it. But after I show you an example of how to use blend trees, I'll talk about why this might be useful for Zelda. So, um, let's get started off. So, what I have here is just an empty Unity project. I've made basically a couple sprites, basically just like a stick figure character with an idle animation and a running animation, and I have this animation both in its right and left form. So the first thing I'm going to do is I'm going to take these individual sprites and turn them into animations, Unity animations. So there are a couple different ways to do this, but in my personal opinion, the fastest way to do this is to select all of them in the project thing and then click and drag them into the scene. And what this will do is it'll pop up I believe this works in Mac as well. It'll make a pop up for you to save this. So I'm going to save this as idle left. And then I'm going to go ahead and do that with the rest of these. So this will be idle right. I want to save this in my animations folder. Here's run left. And run right. That's a little bit tedious, but you'll have to do this for all of your. Let me delete these from the hierarchy as well. But basically, in your games, you'll also have to make all of the different animations for all these different sets of sprites that your characters and enemies have. So you'll notice that it will create a bunch of animation controllers automatically when you create animations this way. We don't want any of these, so we're just going to go ahead and delete them. We do want one animation controller to use with all of these though, so I'm going to right click, I'm going to click create, and I'm going to choose animator controller. And I will call this movement. So I'm going to double click on this and it will open up the animator window here. The animator window starts off with some default values in it. We're going to keep those in here. But the thing that we're going to do next is we're going to right click and we're going to say create state from new blend tree. And remember that blend trees are sort of the system that we're going to be using. Right, first off, I'm just going to show you how to use them and what they'll look like, and then I'm going to explain a little bit more about what they're doing and why they're useful. So I'm going to create two blend trees here. This first blend tree, I'm going to rename in the inspector to idle. And the second blend tree, I'm going to rename in the inspector to running. The next thing I'm going to do is I'm going to right click idle. I'm going to click make transition and I'm going to click on running. I'm going to do the same thing, right click on running, make transition to idle. And all that says to the animation controller is that we can go from idle to running and we can go from running to idle. The next thing I'm going to do is in the parameters window here, I'm going to add a Boolean. I'm going to call this Boolean is running. And in the inspector, for each of these transitions, I'm going to click on the arrow that gets created for the transition. I'll remove has exit time, remove fixed duration, and set the transition duration to 0. The reason I'm doing that is because the sort of each frame of the sprites we're using are discrete, and we don't really want to be transitioning between the sprites of the idle animation and the sprites of the running animation. We just want to switch immediately to the next animation. So we're going to set all of these values to 0, but we're going to add the condition is running true. And then for going from running to idle, we're going to do the same thing. Set all of these to 0 and uncheck the boxes. Set is running to false. So this is running Boolean. We're going to pick up on this in the script that we write for movement. But when this is set to true, it'll move the animation from idle to running. And then when we set it to false, it will go from running to idle. So now that we have these blend trees set up to transition between each other, we're going to double click on one of them. So I'm going to start off by double clicking on the idle one. So what you'll see here, it says blend tree, and then in the inspector, it says blend type 1D. For the example I'm showing you here, we're going to keep it as 1D. When I'm talking about how you can apply this to, say, the Zelda game, if you're doing the Metroid game, since Samus is facing sort of these two directions, 1D will probably be enough for you. But in terms of Zelda, since Link can move in 4 directions, you're going to want to go with 2D. I'll get back to that. So with 1D, I'm going to... Okay, the other thing we need to do before we can actually click on the blend trees is we're going to create a couple of float variables. I'm going to create a float variable called dirx. Then I'm going to create another float variable called previous dirx. And the reason for this is when we go from the running state back to the idle state, we want to, in our idle state, we want to check before we stopped moving, were we facing right or were we facing left? And that way, the idle state will know to set our sprite to the right facing or left facing animation. And, if you're doing this in 2D, you'll have a dir y and previous dir y. Anyways, I'll go to the blend tree. What I'm going to do is I'm going to add motion field, and I'm going to click on this twice. I'm going to uncheck automate thresholds. I'm going to set this threshold to -1. So let me expand the inspector a little bit for you. I'm going to set this threshold to -1. And then what I will do, in my project, I have all these animations. I'm going to drag idle left to here. I'm going to drag idle right to here. And that's the setup that we need to do on this blend tree. We're going to go ahead and do the same thing on our running blend tree. We're going to click on this in the inspector. The other thing I forgot to do, sorry, let's go back to the idle blend tree and let's set its parameter to previous dirx. Because remember, in the idle, we're going to look, when we're not moving, that's when the idle animation plays. And when we do that, our dirx variable is going to be 0. And when it's 0, it's going to just set it, and it's not going to choose which direction. That's why we're going to use prev dirx, which we'll be setting in our code again. But with running, we're going to set the parameter to dirx. We're going to add our 2 motion fields, -1 and 1. And we'll have run left and run right as our things here. And so what this blend tree is doing is, depending on the value of the parameter dirx, it's going to either show the run left or the run right animation. And similarly, on our idle blend tree, depending on the value of previous dirx, it's going to either show the right idle animation or the left idle animation. So now that we have all our animator stuff set up, the next thing we're going to do is in our scene, in our project hierarchy, I'm going to just create a sprite. And I will give this sprite initially just the idle animation sprite, set its transform to 0, set its scale to 5, so we can see our guy over here. And now that we have that, we're going to write our, we'll name this sprite player, and we're going to write a player movement script. So I'll call this player controller. And it'll get created. I'm going to go ahead and in Visual Studio Code, I'm going to open this up. We're going to need a couple things here. I'm going to first create a public float move speed. I'm going to set this to 1f for now. And then I'll have an animator anim. I'll say animator in start. We're going to set animator equal to this dot get component animator. And now that we've done that, we should make sure we actually have an animator here. So let's add an animator. And we're going to give it the animation controller we made, our movement controller. All right, now let's go back to our code. What we want to do is just so that I remember, I wrote this in advance as well in case I forget all of the things I need to add to the script. So let me open up my backup here so that I don't forget here. Right, the other thing we want to set is our float previous dir x. You'll remember that in our animator, we have this parameter called previous dir x, and we're going to want to set that value as well as the dir x value. So we're going to create a variable to store our previous dir x value. After that, we're going to go ahead and in the update function, we're going to have a vector 3, and it's going to be our movement vector. And it's going to equal vector 3.right. So again, in this example, the player can only move right and left, but I'll talk more about, up and down and how to do this in 2 dimensions as well. So we're going to do vector 3.right times move speed times time.delta time times input.getAxis horizontal. And we're going to check if our movement vector's x is equal to 0, which it will be if we're not moving. If that's the case, we know that, hold on. Well, first things first, we're going to do transform.position plus equals movement vector. And so we're always just going to be adding the value of the movement vector, which will either be 0 or one of the directions to our transform. If our movement vector is 0, then we're going to set the value of prev dir x to the current movement value. So we're going to say, hold on. That's right. Animator.set float previous dir x. We're going to set this to previous dir x. And then animator.set bool is running false. I believe we named it is underscore running. I can go back into the Unity and check. We can see here in our animator that is the Boolean we have here. Else, that means, so I'll comment this, not moving, we want to go idle. Else, moving, not idle. So we're going to have, animator.set bool is running to true. So similar to false, we're setting this to true because we're moving. We want to make sure we've transitioned to the moving state. And we're going to set our previous dir x value here to our movement vector dot x. So the reason we're setting this here is because we want the value of previous dir x to hold what the value of dir x was when we were moving. So we want to set it during the time that we are moving so that the first run of the update function when we're no longer moving will go here, and the value of previous dir x will be whatever dir x was when we were moving. And that's what we want to tell our animator so that our animator knows which direction to face. Finally, we'll also set animator.set float just our other dir x to movement vector.x. So we've been writing a lot of code without checking it. That's never a good thing. Let's go ahead. Let's go to the Unity editor and let's check. If everything worked out as expected, then what we will see is that our character will have both a left and right idle and moving animation. So make sure you're taking a look at the game window over here when I click play. So looks like we have the left idle animation playing. And if I click right, we have the right idle animation playing. If I press and hold right, looks like we have the right sort of moving animation. And then I stopped moving and it switched back to the right idle animation. I'm going to go ahead and press left and see how that goes there. Looks like we have the left moving animation working. And then when I release the left arrow key, we switch over to the left idle animation. And looks like everything's working as expected and as we wanted. That's pretty exciting. So this example that I did here is for a character that can only move left and right. You might be wondering, if you're doing Zelda, how this might apply to you. So blend trees, you might have noticed the blend tree we set to 1D. Blend trees also have something called 2D simple directional, which is what you're going to want to use for Zelda. You're going to have more parameters here. You're going to have dir y and previous dir y. And you're going to have animations for all 4 directions. And what your blend tree will do, your blend tree will have 4 motion fields instead of, 2. And, you'll use, you're going to basically want to be doing this depending on, like, let's say, let me create 2 empty animations for this real quick. Idle down and idle up. We'll add idle down here and idle up here. And idle down will be that. Idle up will be that. And you can see, similar to that 2D blend chart we had, we're going to want to set this to previous dir x and previous dir y. And you can see, depending on what the values of both of these is, the blend tree is going to decide which of the 4 animations to play. And so you can apply the exact same principles of what I did on the running animation as well. And, in your movement script, you'll have both X and Y values here that you set. But other than that, it'll be the exact same sort of thing that I've shown you here. And why is this useful? Well, I know I'm talking a lot about Zelda, but this is that's sort of the game that I think this is a great example for this. In Zelda, Link has 4 directions he can face. He can stand still facing those 4 directions. He can move in either of those 4 directions, and he can swing his sword in either of those 4 directions as well. So if we were to do this not using blend trees and just using like a sort of state machine with each separate animation and transitions between them, you're going to get a very complicated web that's very difficult to debug immediately, to try and get all 4 directions, all 4 types of movement and sword and idle. And that not only makes it hard for you to debug, it makes it hard to add any more animations. It makes it hard for us to help you in office hours. And overall, it just is really confusing to make sure it works correctly. On the other hand, the blend tree lets you sort of abstract away the idea of the directions, up, down, left, and right. The blend tree will take care of the direction that it's going to show based on the direction the character is moving. And all you have to worry about is moving between idle and moving and swinging the sword. And you can create the transitions between the blend trees as such. Again, Metroid also, this comes in handy. Because Samus does move in 2 directions, You could easily just be inverting the sort of the transform scale to be -1 to be facing the other direction. But another way to do this would be to do it sort of the way that I've demonstrated here. And that might make things less confusing for you. I personally would recommend considering it at least if you think it would be worth rewriting your animations to use blend trees. And even if you don't end up using this for Project 1, this is another tool in your tool belt for Project 2 and Project 3 that, again, one big part of this class is giving you tools for your tool belt that make you better, game developers, more efficient game developers, and, nothing's more efficient than reducing clutter and confusion in your animations. That's all I really had prepared to talk about in terms of new stuff. At this time, if people have any questions at all about what I talked about, or if they have questions about lecture material, I'm happy to review some lecture material with you. Yeah. Cool. Looks like there really aren't very many questions. So in that case, I'm going to go ahead and stop the recording. Thank you so much for coming to the first discussion.